Hi, my name is Johanna Franklin. I'm an associate professor of mathematics at Hofstra University. My research is in kind of the intersection of probability and computer science, and I'm going to be talking about some thoughts I've had about the book Weapons of Math Destruction by Cathy O'Neil. An algorithm is really just some sort of mechanical process for making a calculation. You take some inputs, you get an output. So at its most basic, it could be taking 2 plus 3 and adding them and getting 5. It could be taking the heights of everyone in our incoming freshman class and averaging them out and calculating the average height of our new Hofstra students. Or it could be something really complicated, like an insurance company trying to figure out your auto insurance premiums. I run the actuarial program, so this is what I think of. So for instance, when you go to get your car insurance, they're going to ask you for your age, your gender, your marital status, your address, the make of car, how far your commute is, your driving record, some other things, and then they roll all of these into this single number of your premium. And that's more the sort of algorithm that O'Neil is talking about in her book, something where you have a lot of different sorts of input and you come together and you get just one number. You've reduced all of these factors about you to a single number. O'Neil mentions an algorithm that it takes in information about a teacher's students' standardized test scores and gives some sort of number on a scale to say, should this teacher be fired? So it's not always a dollar amount, but it could be a yes/no answer. It could be a number on some sort of sliding scale, but it's always just one single answer, one single output. Okay, so I'm talking about algorithms as just something a computer program can do, and a computer doesn't seem like it can be biased, but someone has to write the program, and those people might be biased, or they might not be biased, but they might be using data that is somehow unwittingly going to bias the result. So for instance, suppose that someone from my town is determining auto insurance premiums, writing the code for that, and they write in a code so that everyone with my zip code gets a $50 discount. I do not think this happens. I would like to say, for the sake of anyone in the insurance companies watching this, I don't think that you do this. But maybe you want to have some sort of little randomized effect, and so you might put in some little function based on the person's first name, what their first name starts with, maybe, what letter. So if, for instance, you aren't thinking this through, and maybe people with J as the first letter of their first name end up paying a little bit more, well, all right, now you've somehow accidentally created an algorithm that's slightly biased against people with their first name starting with J. And so far that just sounds silly and little, but let's take this a step further. Maybe more women than men have first names that start with J. Well, in that case, you're overcharging women. Maybe people from one ethnic group tend to have first names that start with J. Well, now you're overcharging that ethnic group. So something that was small and unintentional and not obviously correlated with any particular group of people, well, maybe there's a hidden correlation there. So for an algorithm to give unbiased results, the people who programmed it would not have to only be unbiased themselves, but actively guard against using data that in itself was biased or was not representing the thing that they wanted it to represent. But I think that that's going to be a really hard thing to do for any very complicated algorithm, one of the weapons of math destruction that O'Neil talks about in the book. So I would say that maybe the important thing is not for the algorithm to give unbiased results, but the people who are interpreting the results of the algorithm to be able to recognize the cases where the algorithm is not going to tell you the thing you want to know. I would say that it would be important for us to know what factors go into the algorithm, but most of these are kept very, very quiet, very proprietary. So I think that that's going to be a very difficult thing to have happen in real life. But I think it would be reasonable to push for these companies creating these algorithms to rate teachers, to determine questions of healthcare, of anything that's very important to a lot of people, just to say, here are the things we take into consideration. Here's what you should think about as you interpret the results.